Okay, my name is Jason G. My work is data application architect. I help business. Okay, I help business to build their data application system from data infrastructure to the data analysis platform. And also I part-time I'm teaching at the USC, University of Southern California. Before that, I worked for Symantec for many years as a big data engineer and also data scientist. We use deep learning technology to build a security application. Today, I would like to talk about the data science project lifecycle, and also a little bit about the skill set. Digital for the product manager, the system architect, also the higher managers. When start their project, they want to build their team. So they have to go through the whole, learn a little bit about the whole project cycle, and also help the people who want to. Okay. Also, for the people who want to work as a data scientist. Okay. So data science project life cycle, that is the whole process, when we build a data science, project. The output from this project is recommendation system, fraud detection system, whatever, the business, project. You have to go through project, life cycle. It starts from business requirements, the data acquisition, the data preparation, modeling, evaluation, then you deploy to the production line and collect data from the operations, and then get feedback from the system and optimize your models there. This is the whole project life cycle. And when I was in school, my major is artificial intelligence. I did some research in data mining. At that time, data mining is a technology about, find the patterns, the insight from the data. But data science is a little, different. I talked with Cal a couple of times about, it totally starts from business requirements. When I do the consulting work, some startup company, they don't have any data yet. But we help them to build, data science system there from really scratch. We help them to collect the data, build the model there. So for the data scientists, we need to work closely with the business people, the product manager, the PGM, and we need to learn the business, understand the data there. And also, the first step is we need to specify the business requirements for this particular project. A couple months ago, we have a project. It's about healthcare. We got 15 million records from multiple hospitals, and the purpose for that project is we want to build a model for readmissions. Readmission is a case that, when the patient has been released from the hospital, but unfortunately, they come back. That is a key value to, to evaluate the health system, the hospitals, evaluate their, quality. But unfortunately, in our team, we don't have anyone who has healthcare background. So we spend a lot of times, talk with the doctors, the operations, the staffs, to understand what is their business. For instance, DSCWT, I don't know that at all, but you need to learn what that means and then to use that as a feature when you feed into the machine learning model there. So the first step, we learn the data and then we learn the business and then we specify the requirements. The requirements is, we want to, a prediction model to forecast the readmission. So to help the hospitals to improve. Okay. So after we have the business requirements, the next step, we need to find the data. Where the data we can use. So a lot of companies, they already have the production line. So for instance, Amazon, they have millions orders. Symantec, we have a lot of data from our clients, okay? But we also can find the data from other parties. You can purchase third-party data. When we working on the healthcare project, we purchase data from the hospitals, and also we can use social network, Facebook, LinkedIn, and also you can build web crawler to download data. And also, we have a lot of open source there. The open data is a big project. Open-data.org. You can find a lot of data there. So after we find the data, the challenge for the data part is how you can store your data and manage the data from different resources. But we are lucky because in the past 10 years, the open source big data infrastructure, Hadoop, Spark, help us to store all the data there, right? Each file has 3 copies, also they have, Hive, have a system that, use the SQL syntax to help you to deal with Hadoop. You don't need to learn Java things. You can just use Hive to operate the big data infrastructure. So you will see the data source came from your legacy system, your OLAP system, your web crawler, your open source, your third-party data, and we put all these things, different structured data, unstructured data, we put them into Hadoop Spark, and then we can extract the data from this data lake, use a small part of the data for the analysis. So all the companies, they use this layout to manage their data system. Okay, so we have, after we sieve the data into the other system, so we will prepare the data set so we can build the models. So it's all about the quality of your data. So you have to clean your data there. For instance, some of my students, they were working on the Airbnb project. When they deal with the value for the age, the age should be between 0 to 100, but they found 1,994 this value in their age, values. It's kind of weird, right? So we figured out why. Because there is a bug in Airbnb system. They take the year as the age, so it's totally wrong. Okay, so your first job is find something wrong in your data and clean up. So the challenge for the data preparation part is do the integration. Like I said, you can do crawler, you can buy data from third party, you can have data from your current system, but how you can link them together. But that's the tough part. Okay, ETL give us the process to load the data, but you need to figure out the correlation between all the data sources. And the next step is feature engineering. Okay, a lot of data scientists spend a lot of time in the data feature engineering. We use we can use some brainstorming. We did a lot of brainstorming in our team to figure out the features we can use. Also, we use some algorithm to generate the features automatically. So whatever you use, you have a initial, data set for the features, and then you research the features, you do some tests, you try different algorithms, the modeling, and then you change the test set. This is a cycle. We do a lot of work to test, validate, and create a new and drop the other one. It takes a while. And then you go next step. You have all the feature set. You do the modeling. Okay. The first question is which model you will use. Okay. I borrowed a chart from. Well, they have a beautiful chart to help you to figure out which algorithm you should use. The quality for your data application is totally depends on first your data quality, the second your features, the third is your modeling, the algorithm to model the process. So a lot of the case we choose the model based on the business requirements. For instance, if you build user segmentation, you can use clustering. If you build a recommendation system, you can use classifications. If you deal with social network, I think a graph database is a good one. You can use a lot of modeling algorithms in graph database. So after we build the models, so finally we want to put that into production, right? So at this point, you can deal with. You have to learn something about Lambda architecture. That's the architecture used in a lot of companies. They build large-scale data applications. Lambda architecture, we have 3 tiers. The first tier is batch processing. Like in Amazon, they save a lot of logs from their old lab system and put that into their data backend and process that as a batch process. And also we need some real-time data pipeline to deal with some particular case. For instance, when Amazon do the recommendation, they need to collect your keywords you put on the search bar, right? The order you just put. So all this kind of data should go along the real-time data pipeline to fit into the recommendation system. And your application, your model should put into the service layer, just like we show in at the middle of the chart. Okay, so I quickly go through the whole process for a data application project, and for the hire managers, when they build a team, they are looking for different skill set. Thank you, Kyan helped me to build this beautiful chart. We need statics. We need some engineer to build the data visualization, the dashboard, and also we need software engineer to build the products. We need a data scientist to do the machine learning. We need data engineer to process the data, to collect the data. And also we need data scientists, the product manager to do the communications. And also we need the domain expertise, to teach us, the healthcare domain, learn, all the business there. So if you want to work as a data application project, you can find a lot of opportunities from the very bottom. The first stage, when we do the business requirements, if you came from a business major, you can try to figure out the problem, and then clean up the business requirements, and then talk with the data scientists, right? And for the data engineer, you can do data collection, you can do data processing, and now some of the data scientists, they also working on this part. They spend a lot of time. And then we do the modeling, we do machine learning, we do descriptive statistics modeling, and we do data visualization, Tableau or some other technologies. That is the whole process. There are a lot of opportunities for data scientists, data engineer, business analysis, product manager. Okay. So that's pretty much what I want to talk. And if you have any questions, I know we have a break after. We can talk during the break. And thank you all. I will pass.